Hi everyone, welcome to this episode of Keipert Labs. In today's video we're going to talk about aldehydes and ketones. So we're going to start by looking at what we call carbonyl compounds, kind of this overarching kind of group in which these two types of compounds fall into. We're then going to discuss in some detail about aldehydes and then talk about ketones as both types of carbonyl compounds. So firstly, what do we mean by a carbonyl compound? Well, carbonyl refers to a particular functional group, specifically a functional group where we've got a carbon double bonded to an oxygen. And then that carbon attaches to two other things. Now, depending on what those two other things are, we can classify a compound as either an aldehyde, which are also known as an alkanal in a more technical sense, or a ketone, which are known as alkanones. So we're going to go through each of these in turn now. So this is the general formula for an aldehyde. So you can see our carbonyl group here. We've got a carbon group attached to one side and then a hydrogen to the other. Okay, so if this is the general structure, then this is an aldehyde. So aldehyde, so this carbonyl group is attached to the end of a molecule. It is the very end carbon. And then this R group could be whatever size. It could be a single hydrogen, it could be a big massive ring, a long chain with branches, whatever. That then this will be on the end. Okay, aldehydes are better known, or more accurately known, I should say, as alkanals. Now, the reason that we still persist with this name of aldehyde is just that it's more commonly understood and referred to by chemists worldwide. So the alkanal is the IUPAC technical name, but aldehyde is the name that we will use to refer to them. Okay, based on the fact that they're called alkanals, that these substances get the suffix of al at the end. So we take the alkane, so ethane, methane, propane, we drop the E and we put Al at the end. So they're very similar to what we would do for alcohols, which is OL, but it's the Al. So try not to get them confused, even though it's easy. So if we look at some examples, we've got methanal, we've got propanal, and we've got pentanal. Okay, so you can see whether we've got one carbon, three carbons altogether, or 5 carbons. Notice that even though this is a carbonyl group, that it forms part of the carbon chain. It's part of what we would count in terms of when we're looking at our stems. So we don't say this is, ethanal, where this is attached to the side somehow, that it forms part of the carbon chain. Okay, now what you can notice with these is that none of these compounds, I mean they're just 3 small examples, but none of them use locants. That is, it's not pentan 1-al or propan 1-al. The reason for that is that for it to be an aldehyde or an alkanal, that this group must always be on the very end. And so by definition, for it to be an aldehyde, it can't be at any other position than carbon number 1. And so the 1 is not necessary because it's a given. If it's at a different spot, then it's not an aldehyde anymore. And we give it a different name with a different suffix. And we're going to look at that in a second. Okay, and so you can see that this is, so that's always just going to be that compound. There's no locant needed for the al. But what if this is not a hydrogen? Well, that's where we form compounds we call ketones. You can see that both of these are carbon groups. They could be the same size, they could be different sizes, they could be very big, they could be very small. It doesn't really matter. The idea is that neither of these is a hydrogen. They're both carbon groups, so that makes it a ketone. Okay. Ketones are more accurately known as alkanones by our IUPAC rules. So we have the suffix of "one" at the end, whereas aldehydes had al. Okay, so we can see we've got propanone, we've got butanone, and we've got pentan 3-one. Now you notice that we didn't use a locant here for propanone or butanone, but we definitely needed one here for pentan 3-one. So a locant is needed for when we've got pent or more. Now the reason that we don't need it with these ones is that for propanone there's literally only one carbon that there could be between others. For butanone you could say, right, what about here or here? But remember that then the locants are needed where we get 2 different possibilities. If we move the carbonyl group over one, it's the same compound just flipped around, so it's not actually any different. There's no difference between butan 2-one and butan 2-one, so the 2 is not necessary. If it was on the end, it wouldn't be a ketone anymore, so we don't need locants there. But when we get to 5 carbons or more, it could be right in the middle at spot number 3, or it could be at spot number 2. pentan 2-one and pentan 3-one are different compounds. So we do need the locant there. And then once we get to 6 or 7 or 8 carbons or more, then it's obviously very necessary to use a locant. Okay, and then just like we're used to doing that, we put the number directly next to the suffix. So 3-one rather than 3-pentanone. Now, you notice that propanone is the smallest ketone we could possibly get. Okay, you can't get ethanone or methanone because it can't be between 2 other carbons if it's any smaller than 3. Okay, so propanone is the smallest ketone there is. It's also known as acetone, which you might be more familiar with as its name. Okay, so we looked at this idea that carbonyl compounds contain a carbon double bonded to an oxygen, and the position of that carbonyl group dictates whether something is an aldehyde or a ketone. Aldehydes have the carbonyl group on the end or terminal carbon. They're better known as alkanals. Ketones have that carbonyl carbon between 2 other carbon groups, and we call them alkanones. All right, thanks very much for watching. Don't forget to like and subscribe. Bye for now.